Okay, let's dive right in. You've probably been there, right? You hear about a cool new site, maybe see it on the news, you click the link, and it's just crawling. Or maybe it's completely down. Well, today we're going to talk about what's happening behind the scenes and what it actually takes to keep a website online when it suddenly gets super popular.
So picture this. Your website just goes viral. It's the dream. Suddenly, millions of people are trying to see your stuff. But that dream can become a real nightmare, fast. All that traffic, it puts a massive load on your server, and if you're not ready for it, your site is going to slow way, way down, or worse, just crash completely. It's a great problem to have, for sure, but it's a problem that can totally sink you if you don't have a game plan.
So yeah, let's get into how we solve this good problem. How do you build something that can actually handle a massive, sudden flood of people? Your first thought, and pretty much everyone's first thought, is what we call vertical scaling. The logic is simple. Your server can't keep up? Just buy a bigger one. More memory, a beefier processor, a faster hard drive. You're basically just throwing more horsepower at the problem, hoping one single superpowered machine can handle it all. But there's a pretty big catch. This strategy has a hard limit. As the source material points out, you can only make one machine so powerful. At some point, you're either going to run out of money because these machines get crazy expensive, or you're literally going to hit the ceiling of what today's technology can even do. So it's a quick fix, but it's not a real long-term strategy for internet-level scale. So if making one server into a giant beast isn't the answer, what is? Well, this brings us to a much smarter, more modern idea: scaling out instead of just scaling up. And here you can see the two ideas right next to each other. On the left, you've got scaling up, that one huge, expensive server. But on the right, that's where the magic is. That's scaling out. Instead of one giant, you have a whole team, an army of smaller, cheaper servers all working together. This is how the big guys, the Googles, the Facebooks, this is how they're built. Of course, like with any smart solution in tech, when you solve one problem, you usually create a new one. Now you have this whole army of servers. So when a new person comes to your site, how in the world do you decide which of those hundreds of servers gets to handle them? You need some kind of traffic manager. And that leads us to the next essential piece of the puzzle, the whole art of directing that traffic. The answer is something called a load balancer. And honestly, the best way to think of it is like a traffic cop for your website. It stands out in front of your whole army of servers, and its only job is to point each new visitor to an open server, making sure that no single one gets totally swamped. So how does this traffic cop decide where to send people? Well, it can use a few different tricks. A really simple one is called round robin. It's like dealing cards, First visitor to server 1, second to server 2, and so on. Or it can be a lot smarter and check the server load, actively looking for the server that has the least work to do right now and send the new person there. It's all about keeping things balanced. Okay, so we've got our army of servers, we've got our traffic cop telling everyone where to go. We're good, right? Well, not quite. This really clever solution actually creates a brand new problem, and it's a tricky one that can make your website feel totally broken. This is what a lot of engineers call the shared memory problem, or the session state problem. It's a weird side effect of having a bunch of servers that, they don't know what the other servers are doing. Let's just walk through an example. It'll make perfect sense. Okay, so imagine you're on Amazon or something. Your first click, your load balancer sends you over to server 1. You find a book you want, you click Add to Cart. Now that little piece of information, that this book is in your cart, is stored in the memory of server 1. Then, a few seconds later, you decide you want to check out. So you click to view your cart. The load balancer, just doing its job, sees that server 2 is free and sends your new request over there to keep things efficient. And poof, your shopping cart is empty. Where to go? Well, server 2 has no idea what happened on server 1. It has no memory of that book. It doesn't know you have a shopping cart at all. For the user, it feels like the site is totally broken. And that's a complete disaster for your business. So the fix for this is to take that shared info out of the individual servers. Instead of each one having its own little memory, you create one central shared database that they all talk to. Think of it like a central brain. Now, it doesn't matter if you land on server 1 or server 200. They all look to the same place for your shopping cart info. Okay, problem solved. Except in fixing that problem, we just created a huge new one, a massive single point of failure, right? You could have 1,000 web servers all humming along, but if that one central database goes down, your entire website is dead in the water. It's like you fixed a leak in a dam just to find an even bigger crack right next to it. And this brings us to the final and maybe the most critical idea in building for huge scale. You have to start designing for disaster. You have to expect it. The magic word here is redundancy. The entire philosophy behind modern, high-traffic websites is to just assume that every single part of your system is going to fail eventually. Not if, but when. The hard drive, the server, the power supply, something will break. So you build a system where nothing is a single point of failure, because everything has a backup ready to go. So how do you make that critical database storage redundant? Well, one popular way is a technology called RAID. Let's just look at RAID 1. It's called mirroring. It's simple. Every time you save a piece of data, it gets written to 2 separate hard drives at the exact same time. So if one of those drives just dies, no big deal. The other one takes over instantly. Now the downside is, it costs you twice as much for storage. Other types, like RAID 5, give you a different balance of safety and cost. It's all about picking your trade-offs. And we can use that same idea for the database software itself. A really common way to do this is called master-master replication. Basically, you have 2 identical master databases running. Every single change gets written to both of them at the same time. If one of them fails for any reason, the other one is already running, completely up to date, and takes over immediately, no downtime. That single point of failure, it's gone. And that's how we get to the final picture. A truly tough, scalable system has this idea of redundancy at every single level. You don't have one load balancer, you have a backup pair. You have your whole army of web servers, and your most important data, your brain, is safe and sound on databases that are constantly being copied to a backup. Every single point of failure we've talked about has now been covered. So you did it. You built this amazing, complex, resilient system that can handle almost anything. But the job is never, ever really finished. Now that you've solved for all of this, what do you think the next single point of failure is? Is it the one power cord plugging everything in? The one network switch connecting your database servers? Is it the entire building? The hunt for 100% uptime is just a never-ending cycle of finding and fixing the next weakest link in the chain.